So we talked about light travelling in a bendy line?
No.
A zigzag line?
No.
Straight line?
Yeah.
Okay, can you show me?
Year 6 class teacher Rachel Dixon has just finished her lesson on light. She discusses with 2 colleagues why she took that particular approach.
The thing with light, it's a bit ironic, but of course we're teaching children how they can see, but we can't see how we can see. We can't see the light very easily or what is happening. So this poses a real problem. So what we're going to do is we are going to set up our model, okay?
I like the model that you used with the mirrors and the ribbon. Why did you choose that?
We used ribbon to sort of demonstrate that that was the light travelling. What was really interesting was it didn't actually work for every child at all. Some children found that obviously light maybe bends, it goes around corners, and we had children moving the ribbon around the teddy bears that they were using. And of course light doesn't bend, so that was something else that we had to then discuss.
So how did you deal with it when you came to children not understanding and the ribbon bending round?
We looked at what they did and said, well, hang on a minute, light doesn't bend, it actually reflects from the object. So actually, where the ribbon isn't perfect, the whole discussion about why the ribbon isn't perfect then leads to their understanding.
I think what's particularly strong about using the ribbon as well to model the path of light, and quite a complicated path, was when children were confused and when they were getting it wrong, they could work together to do those corrections rather than having a book with loads of crossing out or rubbing out and I just don't get it, I can't understand it. There was a group where the ribbon was a bit bendy and you could see that one of them was saying, no, step back, and it became straighter, and they were planning that path of light together. I think that really supported them. And then when they would eventually come to draw the model, which is what they're going to have to do to demonstrate for somebody else outside the room, more children would be successful.
I'd like to pick up something I noticed in your lesson, and that was quite quickly you changed the space in which the children were working. I wonder why you do that.
That's something that's quite natural for the teachers here, actually. We really encourage teachers to make as much use as possible of their environment within the school and close and outside school as well. So quite a lot of science will take place in the playground if you need a bigger space for modelling or to do with shadows and things like that. We've got trips and links with the local rangers in the local parks, because our children don't know if they haven't experienced it. And yes, you can show them a video or you can show them a picture, but it's not the same as being there and smelling it and feeling it and becoming part of something.
Shall we do the torch first, the source of light? Alright?
I was interested to see you use the whiteboard at the beginning of the lesson. Do you usually do that?
I tend to use whiteboards in almost every lesson, whether it's maths, literacy or science. In science in particular, it's really good to get their ideas down, to see what they know, to see what they think. When presented with a perfect crisp white sheet of paper in their books that children then have to spoil by writing in, they think their whole world will end if they get it down wrong on paper. However, with a whiteboard, they feel safe with that because it's not permanent. It's something that they can change and adapt as the lesson goes on. Now, some of you snuck whiteboard pins in here and started changing your boards as you were going along. And I suspect that might be because you actually thought, oh, hang on a minute, I think I might have missed something out on my diagram.
Actually, that was a lovely aside that you made in the lesson as well. You said, oh, I can see some of you have brought your whiteboard pens in. So it was almost like the children weren't confident in what they'd done first of all, but knew that they were going to progress through the lesson and knew that they didn't know what it was, but they would have an opportunity later or before you noticed to change it because they would understand more, which is perfect.
Which is exactly what we want in science. We want to see their ideas emerging and evolving and see that movement, because that offers us an assessment point, a formative assessment point, so we can see how they're changing and then scaffold a little bit more if needed.
Our light source travels in a straight line to the object.
Rachel, I saw the children almost doing karate chops like this, and it was fabulous. What part does that play in their learning?
It makes it fun to start with. It really kind of loses children's inhibitions about, I'm not going to get this right, I'm worried about the language. And if they can start doing it physically and having a bit of a mess around with it, they really, really enjoy that. But for their learning, it's almost the retention of the information as well, the retention of that learning that they're doing. Because, for example, in the next lesson, I won't necessarily use words to cue their thinking. It will be, so this happened and that happened, and they can then actually come up with the language themselves, having been prompted by that action.
It seems is that you are picking up on different ways of accessing children's understanding and allowing children to tell you about their understanding and each other. So you have the whiteboards with their diagrams, their concept diagrams. You've got this actions and words. You've got them working together and explaining to each other, modelling a concept. It seems a very rich environment, offering children of different abilities access to science. So it's really inclusion for all, isn't it?